So yeah, thanks for letting me come and talk to you for 45 minutes or so. A bit about me. I work as a lead server developer in this gaming startup in Finland. We founded the company 5 years ago to build our first game, Supernauts, which launched on iOS and found some mild success. Apple featured it and then it kind of died. And after that, we've been working on four smaller projects, and all of them do have a backend, and the backend has been Elixir, or one of them I'm kind of porting to Elixir now. And so what I'll try to talk about is a few words about my life before Elixir, because I think it might be interesting in it, and it kind of like shaped how I look at Elixir. And then I'll try to scratch the surface on how we build our services for the games now. And while doing that, I'll try to share my experiences or our experiences and what we learned on the way. I hope I can get that across, at least some of it. And so this Supernauts game, even though it has nothing to do with Elixir, well, I'm going to talk about it a bit. It was this like MMO game where everybody could go and build their place in space, and it was written in C#, the client, and the server was actually this C# server, this really big monolithic thing that was running this voxel world where there's actually simple physics simulation going on, NPCs walking around, and in addition to that being heavy, we also decided to build everything on the C# VM. So it was doing everything possible under the sky, like running the simulation, doing in-app validation, running a friend system, running high scores, and a lot of different containers, running stuff concurrently, taking messages in. And my life looked like this for a while. I was looking at dumps or logs from the server. When we increased the concurrency on the servers on a load test, we'd basically be able to crash the whole VM. It was the best case was that I would get an exception that would tell maybe where the problem is, but comparing to Erlang, where you actually, when you get an exception, you actually know what came in, what was the message that came to the process, what was the state of the process, and why it crashed. In this world, it was more like you have exceptions, maybe you can try to figure out, debug what's going wrong in the code, and in the worst case, I only know that, well, the whole VM crashed and everything it was doing is now gone. And another thing in this world is that we have the garbage collector that will actually stop the whole VM when it decides to do some heavy work. So if somebody is building in their world, and I have a message coming in and the garbage collector decides I'm gonna kick in now, everything is going to stop, and that gets you into like really hairy, tricky stuff pretty fast, because you have to think about how you're managing the memory, and the tools that I had at my disposal were basically just taking snapshots of all of the memory that's in the VM, and I could see things like, there's a lot of blocks in the memory. Well, that's probably okay, but there might be something else, and you just like take these snapshots and try to figure out what's going on. And that's, yeah, just explosions and really not so much fun stuff. But there was a beacon of like light and hope that we built this load testing client on Erlang. I don't know why we ended up doing only that on Erlang, but we had this load testing cluster that we could use to hammer our servers, and for I think maybe 2 months we did this, that we'd ramp up the concurrent connection amount, and we'd see the servers crash, or we'd see our MongoDB, which was another thing that would burn. And without the Erlang thing, I don't think we could have actually launched the game and have a successful launch. And yeah, that picture was from the output that the load tester cluster would produce, that we could map out like how much concurrent users we have and how the latencies to the engine are, and try to figure out what's going on. We'd have a lot more graphs. And well, one of the things I learned while doing this, that one of the things I ended up doing was like a lot of this plumbing code, like that I call it plumbing, this low-level stuff like building the server connection listener that's taking in the TCP connections, but because what the SDK and the standard libraries are providing aren't really giving me enough, or actually I'd have to try to circumvent some problems that would actually crash the whole VM. So I tried to figure out a way to build the connection listener so it would actually work. So a lot of low-level work that doesn't in any way contribute to making the game. And yeah, that technology just didn't really feel like a natural fit for the backend. We obviously running the simulation and that heavy stuff went pretty well, but a lot of the other stuff the server actually did was taking in messages into a mailbox, and then we'd have our own thread pool where we'd run this little process that would take the messages in from the mailbox and then do some processing, call a function, and then return the state, which sounds like a really, really crappy homemade version of Erlang that isn't scalable and crashes and stuff like that. But we did end up launching it, and this is one of our graphs from the monitoring. It did scale to 7,000 concurrent users in the launch, and that would have not happened without the Erlang stuff. So after that, in 2014, we found Elixir, and so the first project, well, we found Elixir, and we had this some knowledge of Erlang, and one of the server programmers actually had a longer Erlang background. So when we started doing this game Warfield that we killed last year, we wanted to look into Elixir because it's a player versus player game. The clients are always connected. There's quite a lot happening. You have your troops on your side of the screen on the mobile phone, and your opponent has their troops on their side of the screen, and there's this real-time battle going on. You're trying to destroy the other guy's towers, and there's also a lot of things happening. There's a league system where you can, in the high scores, so you're in different levels of the league, and you get rewarded as weekly rounds go by. And yeah, it was a free-to-play game, so there was also the enough validation to do. And we really thought that Elixir would be a language which would be this gateway onto the Erlang VM, and an easy way to get people in the company to learn the language. And what the server setup for this game looked like, it's really simple stuff. It's like we have everything in Amazon's on Amazon, and we basically just have their load balancer sitting in front of the clients. And then we're spreading WebSocket connections to these EC2 instances. And we ran Couchbase for this project because it's just key value stuff we're storing there. And well, I wasn't on the team then, they picked the Couchbase. And then we'd use Redis for the high score tables and a few other things. But really, yeah, it was really simple stuff, and I'm really glad that you can do this kind of simple stuff and take it pretty far. And what it looked like inside the Erlang VM, what we are doing is we have a connection listener which is Cowboy and Cowboy WebSockets, which I believe, yeah, it is what Phoenix is doing also. And then we have our hand-rolled homemade process registry, since Gen server does support that. And how we actually run the players or the games is that we have Gen servers. Each of these players or teams or Gen server that's loading their state from the database when we start it. We look up from the process registry if the player's game is already running when the connection comes in, and you authenticate. And if it's not running, we'll start it for you, and then we load the data from the database, and then we keep it in the memory as long as needed. And at some point, the player or the team will decide that it's been like an hour of inactivity or 5 minutes of inactivity, I'm going to terminate and save. So we save a lot of bandwidth towards the database that way. Of course, if somebody pulls the plug, which actually does happen in Amazon, or whatever happens, the machine goes away. then we'd lose some state. But yeah, it's a game we can give free gems to the players. So this sounds really assuring, I'm sure. And in this case, we'd actually just run one matchmaker process. It didn't turn out to be a problem to have this one process that is doing this really simple task of taking in request that I'm a player, I want to be matchmaked, and then we'd spawn the battle process, which would report the result of the battle to the players and player process also, and to the league process. So it's just a bunch of gen servers doing asynchronous calls and sometimes synchronous calls between each other. So really, you can get really far by just taking the stuff you find in the Elixir and the Erlang OTP. And yeah, I think I should talk about this thing. So the gen server supports the via tuple that was Sasha was talking about it. And we basically take advantage of that we have our own library that is currently just keeping logs in Redis. So we're using the scalable system, and we're introducing this one point of failure, which is outside the Erlang, which might be an interesting choice. But yeah, we're pinging that and keeping a log there that this player is still running and so on, and that enables us to start a game on one node, and then maybe later on another node send a message to it like go away or something else. And just adding this little bit of homemade stuff in front of the gen server actually has gotten us pretty far at this point. And one of the things in this game which I was working on was this league system, which kind of drove home a few points about what you can do with functional programming, and with Elixir, the XUnit, excellent unit testing tools. First of all, what the league system does, it doesn't. Yeah, I'll explain what it does first. It doesn't try to keep a synchronized view for everybody. What it does, when you ask a high score list, the player process will ask for the list from the league system. The league system will actually take in that request, then it will look in the configs which round is now active. If there's a weekly round, maybe a round has ended and you should be rewarded, or we need to adjust your score because we did that we lowered your score when the round ended, and all of that processing would happen, and maybe after that we'd place you onto the next round, and in the next round we'd actually put you in a pocket with 99 other players, so that when you fetch the high score list next time, you see you and the 99 other players, and if you do it a lot, you wouldn't see a list of random players, but you'd see this kind of about the same players as they move up and down, and maybe they change the tiers. And building this system that has time and it has configurations, it has this bucketing thing going on. While implementing it, I really wanted to think about how, since I'm using a functional programming language, and I have this awesome test tool, that maybe I can try to build it first without any side effects. So when I'm doing something like asking which round is now active, it's actually, just a function that takes in the league configuration, and I'll give it a time. And every time I'm actually getting a high score list or asking for or posting a score, I'm also giving in the time that this happened. So I can write the test so that the time is always in the tests. So it's pretty easy to write out tests that, you tested what happens when the weekly round ends. You mock out a bunch of players and you see that one of them gets rewarded, one of them doesn't get rewarded. And at the point when I actually needed some kind of storage, like doing the bucketing, I first introduced just an in-memory version by using Elixir's agents. This is actually something we use a lot, that we build a cache or something. We might use the Elixir's behavior thing to define an interface, and write a ETS-based cache and then maybe Redis-based cache or something else that talks to other database. But I'd use this as a way to finish the library that handles the leaks first as an in-memory thing, and then I'd end up in a place where I have a bunch of unit tests and I have the logic written out, and I'm pretty sure it does what it should do, and then I'll go and actually bolt it on to the game. And at this point, I'm actually not talking to any database, but I can already play around with it, and I can start doing the client side, and I can hone in like what I need to fix from the logic. And after that, I start to think about the hard things about the database, how I'm going to store these, and how I'm going to make sure that the database doesn't grow out of hand if there's a lot of entries. Because I really think that it's just, well, basically you're just doing divide and conquer, like making your problem small. And I've noticed that many times you can make a lot of things just a function. And a simple thing, you don't need any kind of server or agent. And what's different with Java or C#, that if you want to have a function you can call from some class, you'd probably have to make it something like a public static thing. That there's a different syntax for that. And you can't just go and call it randomly and then use it as a part of something that is an entity like a gen server. Like here, when you're writing these tests, you don't have to instantiate some class or instantiate some kind of actor system or something to test it. You can just have a function and call it and see it does the right thing. And I think that it may sound like a really trivial and simple thing. It is simple, but it's also very, very powerful. That you don't have to instantiate a lot of things just to test the one thing. And then another game that I was working on during this and after this was this dungeon crawler roguelite that we did for iOS and Android. And while I proposed for this talk, I was really hoping that this would be a talk about running this in production, but us as a team about a few weeks ago decided to kill that one too. So, but it's yeah. So I'm just gonna, invent something. So even though the client is very different, it's a roguelike, and actually what the client is doing is most of it is request reply stuff, but the backend is basically the same. We're just copying the same backend from one game to another. The only big change is that there's some game-specific stuff going on. We're generating the dungeons the client is running actually in the Elixir code. We have some social features, like when you die, we store your state and maybe spawn a ghost from you into somebody else's dungeon, so your ghost can pester somebody else while they're trying to go through the dungeon. And maybe you get notified when your ghost is killed. And, and since I was working on this, I dropped the code space and went for the DynamoDB service, so I'd have less stuff to monitor. And one of the things we did differently here, the Warfield used JSON and some binary messages, but here we went back to things that are pretty old stuff in a way that this is done forever. But we're using this Google's protocol buffers thing to specify the game state and all of the messages that are passing on the wire. We are compressing and doing something else also to the messages, but it's basically so that we have a bunch of protocol buffer specifications. Yeah, there. No, there. That this would be the authentication message that the client is actually sending. I have this habit of prepending them so that this is client to server and server to client would be S to C. But this is the way that I'm writing a lot of the stuff, like the data model. There might be a hero progression thing message somewhere in the protocol buffers, and then I use that to generate all of the wire protocol code that I need for transforming a bunch of bytes into a Elixir struct or into a C# class, so that in the Unity code we'd have this thing that you could call this game API, send it down, construct a class which kind of feels natural in the C# world. And then this yield return thing in Unity is this coroutine thing that I can stop the execution of the code here and wait for the request to be complete, and then I'll check if it went okay, and I'll do something with the authentication. And if it didn't go well, too bad. And that kind of enables us to only work with the message classes, and what we get back from the server is instantly usable data. There is like a player state that is a class that contains everything about the player we need to know, and we can instantly feed that into the game engine and start working. And since it is protocol buffer stuff, we could also cache it on the disk if we need to store our dungeon state or something we want to retry it, continue it if the application crashes and so on. And what you'd see in the Elixir code would be, in the game process, it's not seeing that a binary frame came in, it's seeing actually these structs that map to the stuff we have in the protocol specification. And well, I've simplified things here quite a bit, but having this, it's pretty, in my opinion, it makes it pretty readable, the code that you can write this, like handle this message structure, and maybe try to use the pattern matching to pick out some variables from there, and maybe add some guard clauses there to handle the message when you're in a specific state. And well, it kind of boils down to it. Most of it is really simple stuff. Just once you have this thing that you can generate all of the things that all you see on the Elixir side and on the C# code are just structures. And one of the things we were doing with this project is that we have this thing on GitHub that we're using to pull updates from Google Sheets. We have our development configs there, and we're just pulling them onto the game server, or we're actually triggering the game server to pull them over. And well, just something I wanted to mention, if you want to take a look at it. It's something that's helped us quite a bit. And one thing with Elixir that's been pretty easy to do is parsing those configurations and transforming them into usable structs. And so one of the things we're doing in the Hero Hack game is that we have these sheets that contain definitions about how we're going to generate the dungeons. So the designer can go in and write, like, if you go into area 1 and dungeon 1, how many floors is the dungeon going to consist, and how many monsters there are, how difficult monsters they are, and so on, and how well it's lit. And then there's a bunch of Elixir code that it will take our game configuration and generate the rooms and the connections between the rooms. And we found it actually surprisingly extendable to do it in Elixir. And I was always waiting for the time that we actually get into some like real bad performance problem with doing this kind of computation in Elixir, but somehow it never came up. There was other stuff. And so in the client you'd see lanterns on the walls and things like that, and that was all done in Elixir. Like, we're picking places in the rooms which are matching to some criteria, which is somewhat natural even to write in a functional language. And even though this didn't go really far, I wanted to do some load testing with a custom client application since we like writing stuff ourselves. So it's an application that just opens WebSocket connections with Cowboy's gun library, and it's there idling and sending some messages, which are pretty easy to do since we can generate most of the wire protocol, and I can just fill out these Elixir structs that I want to send. And I didn't pick any like 36 core machines or anything like that. I picked a machine with a reasonable amount of RAM and just run 2 of them and see where I could get with this setup that would cost me like maybe $1,000 a month. And yeah, the first first thing I did, I noticed that I hadn't configured Upstart properly, which is starting our Elixir XRM release, and at 1,000 concurrent users, it crashed. Well, I couldn't get anybody in, but after that, I could run 32,000 concurrent games on the 2 machines, which is not like millions or hundreds of thousands, but I wanted to mention this because this is like 0 effort from my side. I'm not actually trying to do anything fancy, which is something I'm quite used to in other environments, that I have to try to do some fancy stuff to get the JVM or the mono C# VM to actually work. And this is like me spending few hours and not even investigating possible problems. It just, it kind of works so good, and I could log into the game and go play it, and nice. So, I'm pretty confident that that would probably work. And so after that, I've been working on this, we've been working on this kind of Puzzle and Dragons meets Blackjack mobile game. Yeah, these are like horrible free-to-play games if you think that way about free-to-play games. But yeah, it is what it is, and we like with what we do. So it has a lot of going on. You're playing the dungeons, and you're collecting cards, and you're evolving your heroes and whatnot, and very different game from these two. And yeah, it's the same backend, so it's no point showing the slides. It's actually doing everything else kind of summarized and just tweaked a bit. And it's the same thing. We still have the glorious 2 tables in DynamoDB, which is how we use database, that we have a table for devices that contain a random ID we map to a device and a player ID that device mapped to. And then we have a table where there's a player ID and then a compressed protocol buffer binary, which is like 512 bytes or 2 kilobytes or something. And that is our database. And because we can resolve if somebody is already running, we can talk to that process, or if they're not running, we can load that state back into a Gen server and start running that. So that is the level of complexity we are talking about here. So, but with this game, it started out as a project that was working on Google App Engine, because there wasn't a server programmer, and well, that's the way it went. So that should say server driven. But anyway, it's a client that is really controlling that game, and we're trying to build more things that we want the server to control in the game going forward, because it looks like we're going to take it forward the game. And there you really need to think about things like having something randomly generated. You might have like a chest in some game where you get some gifts out, get some stuff out of it. You really don't want to have that random generator seed in the client, because then you can just put your game offline and try to massage the random generator into a nice state and then continue your gaming and get the nice rewards. Or if the client is generating the there are all kinds of nasty things you can start doing. So here my kind of current big problem or thing I'm trying to do is trying to figure out a path from this really client-driven thing to a server-driven thing. And I think even here, the kind of the way you can really easily extend stuff and have like simple message handlers and simple functions first, and then try to extend stuff later on. Even though you can do it in every language, but here it's felt really natural. So what we're now doing is, while it's in development, it's out on Google App Play, but we are kind of doing a new update on it. And while it's in development, I'm actually sending these events from the client where I'm telling, like, I evolved my hero, or I did this and this and this, and then I'll tell which is the state where the client actually ended up in. So there's a lot of traffic going on currently. But luckily, since the state is a map, and I can also parse the client state into a map. In Elixir, it's also possible to diff the maps. And you can start writing the server logic, and you can have your client going forward, and maybe you can report somewhere in your group chat or what you're using, that there's a client playing the game who has a lot of code and is like doing stuff the server isn't doing, and you can kind of iteratively fix the stuff and still move forward, because a lot of times, it might take a lot of time to implement full features right away into the server. A lot of times, currently I'm now a bit cheating on the validation side, that there might be stuff that is validated, you don't know which ones, and some things aren't so much validated. We get the state in and we just store it, and if it's kind of a state that we don't really trust, it looks like somebody is doing something dirty, we can report it and maybe fix it later. So a bit about the other stuff that is not so much Elixir things. What we're doing is that everything is running on Amazon's web services, and now it's just the most simple things. We're not using any of the fancy services. We're not even using autoscaling. We used to use autoscaling to set so that there's an autoscaling group that has size 1. So if the instance goes away, another instance will appear. And really lean, mostly due to the thing that you can get really far with the OTP and the Elixir, like how well you can configure stuff from mix config, and how easy it is to run all of these services inside Erlang. And we haven't had at this moment we haven't had any problems. I guess there will be, but we haven't had any problems, so it's kept the things really lean. There's no message queues, there's no that kind of stuff going on. It's just processes inside a node or crossing the node boundary talking to each other. And currently we are using XRM to build the releases, and we have a Jenkins box in the cloud that is building them. I've also experimented building them inside a Vagrant box, which I use for local development, because there I have the Ubuntu Linux 64-bit, and I could build the release, but it's just so slow that it's easier to keep the CI box going on, and it's pretty easy for everybody to go and click and build the release. And the releases are really nice because you get this one tar file that you can unzip on the machine and then just configure and start, or just start. We're actually using Ansible for the deployment and actually for creating all of the AWS stuff. And the Ansible is responsible for writing the upstart configuration for running the release. And there's like zero manual setup at this point. We are creating all the SSH keys and all the security groups, the firewalls you use in Amazon, and load balancers, everything. S3 buckets, we use S3 in one case, and things like that. Everything is done from the scripts, so which is really nice because I get to work on the console, which I like the most. Or I mean the terminal. And then some of the monitoring tools we are currently using is this Datadog tool, which is where from the graphs were, and then I'll be using Pingdom for just pinging the client servers from around the world and see what the latency is and if they're reachable, and then Amazon's internal CloudWatch thing. Yeah, so kind of to wrap up some of the things that how we feel about Elixir, or I feel, it's mostly my opinions, not my colleagues. It's really easy to get started, and I noticed that when we started using Elixir in the company, there was like, I don't know, there's some kind of excitement and enthusiasm that sparked that I haven't seen in a while. Like, people got so excited about programming in Elixir, they'd order the books on their own expense and start reading those, and you have all these lunchtime conversations which are just about Elixir, and have you read about this, and have you come across this, and it's just it's really easy to get excited, and that's why it's also, well, it's really easy to get started. The documentation is so great, and well, the tooling is great, and all of you, the community is great, and so I guess we are in place. Of course, this means we are a small company, so so you can say things like this, but it's still fun. There's something that a guy who has really like a really graphics programming background, one of the coders in the company, and really like client background, and he can go into the Elixir code and look at it and kind of get what's happening and start getting into doing changes pretty early on. You are very productive from the start, so I like it very much. And well, we're not building software currently for any kind of really huge audiences, but it's been so reliable from like 2014, everything we've run, that there's like cases we've like forgot that something's running, which might not have anything to do with Elixir, but or like forgot that you haven't deployed to some system for like a month, and it's still there, and it just chugging along, and it's I don't know. I guess this is how software actually should work. But we kind of. We all grew up on, like, we've all been taught very different kind of experiences taught us that it isn't so, but interesting. And one of the things that maybe it's not only Elixir, it might be the OTP design principles and how it's built. It really promotes writing code that you can recycle. And for us running like multiple projects at once, it's been really, really helpful that you can go into another project and look in like how's the in-app validation done here, or how the communication with the shop that is in the application, how it's working on the back end, or how some friend system is built, or so on. There's quite a lot of code that we are borrowing and then tweaking and then borrowing again. So I don't know, there's something that things are simple, sometimes really simple functions, sometimes really simple gen servers that do one thing and they only do that one thing well, and then it's pretty easy to compose. So yeah, surprise.
Thank you. We have time for one question.
Okay.
You mentioned using protocol buffers. What library did you use in the Elixir implementation?
I have such bad memory. Yeah, where is it? Xprotobuf. There's quite a few interesting error cases you can get from the Erlang library it's using, which are maddening. But yeah.
Once again, thank you very much.